Good morning. This recording is for Pre-Algebra Chapter 9, Lesson 1, Introduction to Geometry, Points, Lines, and Planes. You will be expected to know how to identify, draw, and label using the symbolic name of points, lines, planes, segments, rays, and parallel lines. So let's talk about these things. A point is a point. It's a point in space. And it has no size and it has no mass, and it's just a point. It's a location. Location in this case would be location A, and we just call it point A. You guys see where I'm reading over here in the picture? Okay, so then if I were to draw another point, point B, so if I were had A, and that's a point, and then I were to draw another point and call it B, and draw a line through them, it's not a very straight line, but you get what I'm saying, I get line AB. All right, and this is how you would name line AB, and it's very important that you know that symbolic part and see that the fact that it's got a little arrows above it. So if I were to label this, I'd say, well, this is line AB, and I'd have little arrows above the A and the B on the line to show that this is in fact line AB. And you could also name it line BA. And if I had a little cursive letter next to it, like that, I could also name it line N. Okay, so there's several ways you can name lines, and usually they're named off of their points, like A and B, and sometimes they use the little cursive N, but not very often. So make sure you keep an eye out for the 2 points with the line all the way through them with the arrows. Now, if the line goes all the way through the points with the arrows, it means it's a line. Not to be mistaken with the segment. So I'm going to skip down to a line segment. So notice the difference between this diagram and this diagram, right? Those two diagrams. All right, the segment end at the points. So if I were to turn this line into a segment, I would erase the part that goes through the points and have it stop at those 2 points. Now I've officially created segment AB instead of line AB. All right, and segments aren't usually named like that. So that is now what we call AB, and that has a segment. Segments, when you're writing them in the symbolic term, don't have the little arrows on them. See how this one had arrows and this one doesn't? That's because this one's now a segment in the symbolic term. Okay, now let's talk about rays. Rays start at a point and go all the way through another point. So it's kind of like in a segment and a line put together. It's half a segment, half a line, and together they form a ray. So again, a ray is directional, and it starts at one point, it goes all the way through another, and it keeps going out the other end. But it starts at one point, and it doesn't go through that other point. So if I were to name this, it would be ray AB. And notice how in my symbolic term right here, that it's directional, that the starting point is at A and it goes through B. The starting point is at A and it goes through B. All right? And that's because the AB, it starts at A, goes through B, and it's directional. All right? So those are rays. All right. The last thing we need to talk about are planes. And planes are very, very abstract. They are basically where things happen. And a plane is just like a flat surface with no thickness. You could kind of think of it like a piece of paper, or maybe even like the flat part of your iPad. It's just something that's there, that's flat, that things take place on. So again, if I were to stick 2 points on a plane and connect those dots, then I'd have a line on a plane. All right. It contains many lines and extends without end in all directions. Basically, it's just an imaginary surface that things happen on. Okay. Very rarely do I ask you to identify planes. Just understand that, like, whenever you draw something, especially for geometry, you're drawing it on a plane. All right. Now the thing is you can have multiple planes that kind of intersect each other, and that's basically where we get to our three-dimensional object. We have a plane next to a plane that's joined by another plane going in another direction, and that's how we get points in space. Okay, is because of a plane. All right, moving on. So let's go ahead and name some of these figures. So up here I have a object that I've drawn, which is a line WK that stretches through the point T. T is the intersection point of ray TH. All right, and as you can see, one of my lines has been named with the cursive N. All right, so let's go ahead and use this figure that I've drawn in black to identify 4 points. Well, that should be pretty easy. Those are the 4 points. That would be H, K, T, and W, right? All right. Now let's go ahead and name 4 different segments. Now, just because the lines that I've drawn go through my points don't mean that I can't identify them just as segments. So even though I have line WK that stretches through T, doesn't mean I can't say, well, I just want segment WK, where I basically ignore the fact that the line does go through W and K. So if I want 4 different segments, I could say HT, WT, TK, and WK. All right, and I've identified them only as segments based on the fact that my symbolic form only talks about them in segment form. Notice how there's no arrows on all of my symbols right there, which means I'm only concerning myself with the segment portion of that line. All right, now if I wanted to talk just about the lines, like line K, I want 5 other names for it. I'm going to name just the line part. Now, right now I can talk about the fact that the lines go through the points and actually form a line. So 5 other names for line KI, and it's actually line KI because it says it's a line, so therefore I need to treat it like a line with my symbols. Lines have arrows at either end. So let's go ahead and rename line KI. So, oh no, excuse me, it's not even KI, it's WT because I made a different figure before I made this. Okay, so let's go ahead and rename WT as a bunch of different lines. Well, I could have line WK, line TK, line KT, line KW, or TW, line TW. And notice how some of them are just a flip of it, and even though it's kind of directional, it's just another way I can name it. So I have line TW is the same as line WT is the same as line TW. All right, so again, if you're just asking you to rename stuff, you could just flip the letters and get the same line. The only thing that's directional is rays. So that's the only thing you really need to keep an eye on when it comes to just keeping your letters in a specific order when naming things. All right, speaking of rays, let's find 5 different rays. Well, again, since it doesn't matter as long as I'm starting at a point and going through another point that actually continues, we can actually do this. So, let's go ahead and look at the first one. The first one is TH. All right, so line TH. It starts at T and goes through H. All right, that is a ray, and I've even showed it's a ray because of the symbol right there. I also have TW. All right, so even though it goes past T to K, I can say, well, I'm starting at T and going all the way through W. That's a ray. All right, so even though there's more after T on that right side, I could say, well, I don't really care about that, but I'm starting here and going through something else, and that is a ray. TK is the same, starting at T, going through K, and then the same with WK. I'm starting at W, and I don't care that there's more of that line on the left. I'm starting at W and saying that's where I'm starting, and I'm going all the way through K. I'm going to keep going because that's a ray. And then the same with KW. All right, moving on. So let's talk about parallel, intersecting, and skew. 2 lines intersect if they have exactly 1 point in common. So I could say that this line right here, MQ, line MQ, and actually it's a segment, it's not a line. The line segment MQ intersects with MT, MT, come on, I'm not trying to select, I'm trying to draw. Intersects MT because they have a line in common, or excuse me, a point in common, and the point they have in common is M. All right, so that's the intersecting part. All right, 2 lines that lie on the same plane and do not intersect are parallel. So I could say that I have a plane. I'm going to erase this. I have a plane, and my plane is right here. It's right here. It's basically the plane that's formed by M, N, Q, and R. And I can say that lines are parallel if they lie on that same plane and are in fact parallel. And remember that parallel lines, just like when you have no solutions, they never touch each other. So they're on the same plane, but they're just going to keep going straight, and they're never going to touch each other. That's parallel lines. And we use this symbol, and the symbol is very important to indicate that two segments are parallel. So I could say segment MQ is parallel with NR, segment NR. All right, there we go. Alrighty, oh, and that's the example they provide below. Alrighty, so next up is skew. Skew is a little crazy for some people, but it's cool. Skew lines are lines that do not lie in the same plane. If they don't lie on the same plane, it means they can't be parallel. So even though they might look like they're parallel, that they're going the same direction, but they never touch, because the fact that they are not on the same plane means that they are in fact not parallel. So just because they look like they're parallel, if they're not on the same plane, it means they're not parallel. They also cannot intersect. So even though they're on different planes, they can't intersect. So skew segments must be part of skew lines. In the diagram above, so up here, we have MN, which is this one right here, and we have RS. RS are not on the same plane, they do not intersect, and they are obviously not parallel. All right, so there we go. So let's go ahead and move on to the next slide. I hope you guys are taking very good notes, or at least paying very good attention. All right, moving on. So 4 segments that intersect DH, and I didn't actually pick that one. The book did. It just happens to be my initials. All right, moving on. So 4 segments that intersect DH. Well, here's DH right here. So we need 4 segments that intersect that line. So they either have to have D as a point, or they either have to have H as a point, because remember, intersecting have to have at least one point in common. So lines that are in common are segment AD, segment CD, segment EH, and segment GH. So as you notice, each of them have at least one point in common with the other one. All right, it either has a D or an H in the segment name. All right, so let's go ahead and name 3 segments that parallel DH. Well, they have to be on the same plane, so it just matters which plane you're looking at. So since this is kind of a 3-dimensional object in that it has depth, the foreground is what we call what's created by DCGH, and then the background is formed by ABFE. All right, so we can look at these planes as different parts. So if I look at parallel lines and I'm looking at the plane that is made up by DCGH, a parallel line would be CG, which I didn't do first, but that's okay. But there it is. So there's CG. So CG is parallel to DH when we're looking at the foreground panel. Now, AE is parallel to DH if we're looking at the side back panel right back here. All right, that's a plane right there. It's kind of weird to look at, but that's a plane, which then obviously means that AE is parallel to DH. Okay, now if we look at even another one, what's the other one that we're looking at? We're looking at BF. So BF is actually skewed, so I actually don't agree with that one. Though you could probably look at it as just now the fact that we're looking at the plane as DCGH and BF is a segment on that plane and doing that one. So again, I don't quite agree with the BF one, but the book disagrees with me on occasion. Okay, so 4 segments that are skewed to DH. So let's go ahead and look at those. So we have AB, BC, EF, and GH. All right, so AB is definitely skewed. It's not on the same plane, and it's definitely not parallel, right? And then we have another one that is BC. BC, not on the same plane and not parallel, good. And then EF, not on the same plane, not parallel, good. Up too far. There we go. And then we have FG, which is right there. Okay, looking good. Let's move on. This is the last slide. So let's go ahead and do this. So you have to be able to know how to draw these, and you're going to be expected to. So you need to know how to draw parallel lines, and you need to know how to draw segments, and you need to know how to draw lines and rays. All right. and points, but I don't really expect you to draw planes. Planes are a little, again, conceptual. All right, so definitely use your notebook paper or graph paper or the graph paper that's in Notability or even the line paper that's in Notability to help you out. It's very important that you know how to use this and that you know how to use the fact that you've already got some parallel lines if you're using graph paper or line paper already. All right, so let's go ahead and draw 3 parallel segments. I'm going to use the straight edge tool on Doceri, but again, you can use a ruler, you can use the side of a book, just try not to write on the book. Anything that will give you a straight line, use it. All right, so I'm going to go ahead and draw 3 parallel segments, and they're segments, so they're going to end. They're not going to have arrows. All right, and then I already went ahead and did number 2, which is to draw a ray that intersects the 3 parallel lines. So if I go back a little, actually, let's see here, if I go back a little, there we go. So those are my 3 parallel lines, and now I'm going to draw a ray that goes through them. Intersecting the 3 parallel lines means it's going to go all the way through the 3 parallel lines out the other side. So it's going to start, and it's going to go all the way through, and the arrow means that it keeps on going, but because I draw a dot at the end, it means it stops at that end. Okay, so that's 1 and 2, and then I'm going to draw a segment AB, which looks like this. All right, actually, let me show you what it looks like. Segment AB, and again, it's named AB because it has a segment symbol above the AB telling me that the 2 points A and B form a segment. And a segment means it stops. It doesn't go through the points and continue on. So if I'm going to draw a ray, it's going to start at Q and it's going to go through R. And again, rays are directional. They start at one point and go through another, which means when you're doing the symbols, notice how even in my symbol, it starts at Q and goes through R with the symbol. That's how I know where the point has started and what point it goes through. Okay? All right. And then we have line LM, which means it goes all the way through L and all the way through M. Oh no, that's a segment, not a line, Miss DH. Let's fix that. There we go. Now it's a line. Now my symbols are also a line because it goes all the way through and has arrows in the symbol. All right, guys, I'm done. Sorry it was long, but hey, it's graphing and doing fun stuff with lines and stuff. All right, done. Bye.